Hello guys, how are you today? Today we are going to talk about this paper called Redefining the Software Engineering Profession for AI. This paper was recently published in ACM, which is Association for Computer Machinery, and this paper was authored by Mark Russinovich and Scott Henselman. Mark Russinovich is CTO of Azure and Scott Henselman is Vice President in Microsoft. These two authored this paper last year and it only got published very recently in ACM. We're going to look at this paper and I'm going to share my perspective on this as well. So they are basically starting off with this statement. They are saying that we have software engineering professions talent pipeline, and they are saying that this talent pipeline will collapse if you are not hiring entry level engineers to maintain that pipeline. So when they say pipeline, what do they mean? They are basically saying that we'll have this structure, right? So we'll have junior engineers and mid-level engineers, senior engineers and lead engineers. So this is the normal career progression, right? So they will, the junior engineer will become mid-level engineer will become senior, and they'll become lead, right? So this they call as talent pipeline. Normally we'll hire junior engineers. Over time they'll gain experience and knowledge, they'll become mid-level engineers, then they'll become senior, and also over time they'll become lead. So this is the normal career progression. So depending on their ability and aspiration, they will move up the layer like this. So they call this as a talent pipeline. And if you're not hiring people in this entry level area, so they call this as early in career developers. If you're not hiring this early in career developers, then this whole pipeline will collapse, okay, which I agree, because if we don't hire juniors, how do we get more mid-level seniors and leads in the future? If all these people retire, then we will have a void, right? There is no other people who has knowledge and experience to go and take these positions, so that will create a problem. So that is what they are talking about here when they are talking about talent pipeline. And then what they are talking about is, for senior engineers, generative AI is giving AI boost because they know what they want to do. They'll be able to use AI to get that done quickly. But on the other hand, for early in career developers, which is basically junior developers, AI is a drag. This is because companies are trying to automate their role rather than giving them an opportunity, because even if they hire them, companies think that they'll not be able to produce the same amount of output that these senior engineers are producing. So there is a hesitation in hiring these early in career developers. And basically this causes drag for early in career developers, as in they are not able to find a job. So AI basically drags them, or AI is not giving them a boost, it is slowing them down. So that is what he refers to as AI drag for early in career developers. So basically what he goes on and says is that we need to keep hiring these early in career developers, otherwise we'll have problem. So the solution is, they are suggesting something called preceptorship. Preceptorship is like a mentorship, right? So you will guide and help early in career developers to help them to learn and think like a senior developer or seasoned developer. So they'll be able to operate at senior level with some time and experience. So that is the whole idea. So rather than stop hiring these junior level people, we need to hire them and we need to help them to learn the skills from senior developers, so they'll be able to operate independently in the future. So that is the whole idea. And then they go on and talk about AI boost. They are giving some examples. So basically, if you're a senior developer, you'll be able to complete a complex task several times faster. And they are quoting a couple of examples here. The first example is, there is a project within Microsoft called Project Societas, and they're saying that this project, they used 7 part-time engineers, and they completed this project in 10 weeks time. They have used AI to generate 98% of the code. They have overall 110,000 lines of code. So these part-time engineers basically shifted their work from authoring to directing. So rather than writing the code, they were just giving instructions to AI agents, and AI agents were producing the code. So this is one example of AI boost that they are giving. And another example is there is another system called Aspire, it seems, and they have used AI in the human agent swarm mode, which is basically they'll have a lot of agents, they can collaborate with each other to create code changes, and finally they'll create a pull request. And they are saying that only review was done by human and everything else was done by AI agents. And as part of this, they are highlighting an important thing that I think, which is lower opportunity cost for experimentation, because we are able to write code at a much faster rate than what we used to do. We have chance for experimenting many things in parallel, and because of that we have lower opportunity cost. What is opportunity cost? Let's say, for example, you want to experiment 3 things. You only have time to experiment one of them, or you only have time and money to experiment one of them. So you let go other 2 options. You only focus on one of the experimentation. So you are losing out on the benefit that you may get from the other 2 experimentation that you couldn't do. So that is called opportunity cost. And now, because you will be able to do these experimentation using AI agents, you could even do all 3 of these experimentation in parallel with a fraction of the cost that it would have taken in the past with the developers. So basically, with AI boost, we can lower the opportunity costs like this. And then they are highlighting one of the important thing here. They're saying that sometimes agentic AI will exhibit intern-like behaviors. It will not, always come up with the right solution. It might come up with a really simple, silly solution, which is not a right solution. So they are quoting an example for this. Basically, they are saying that one of the code generated had some synchronization issue, and to solve that issue, AI agent introduced sleep in the code. Basically, it introduced some code to make the thread sleep for some time, so the synchronization problem will go away. This is actually not a fix. Okay, so if you know about synchronization, this is not how you will address synchronization issue. This will probably mask the issue. It might make it look like the issue is gone, but it will not be actually gone. If you are early in career developer, you may not be able to spot these kind of issues because you don't have experience and knowledge to do that. So that is what he is highlighting here. And then they are also highlighting that the explanation, the rationale given for this fix by agent A is also not correct. But when it is challenged by a senior engineer who knows about the subject, it was able to admit its mistake, and it was able to come up with a slightly different solution. Okay, so the whole point here is, if you don't know what it is doing, if you naively believe that all the things that it is doing is right, it might come up with some really bad solutions. As an engineer, you will be able to spot those things. You need to have enough knowledge and experience to spot these things and guide AI in a way that you wanted to develop the solution. And early in career developers will not have that knowledge, which means they'll not be able to guide AI and point its mistakes. So that is what they are basically highlighting here. And they are reaffirming that human expertise remains essential in software development. They are also making a very clear and important distinction here. They are saying that programming is not software engineering. So AI agents that we currently have are good at programming, but they are not software engineers. They don't have that skill and knack to develop a really good, well-crafted product or software. They are just a machine which generates code. So this is very important distinction. So programming is not software engineering. Software engineering is a craft. You need to have experience and knowledge to develop a really well-designed, good product. And programming is not that. Programming is, taking a small problem and solving it and continuing that over and over and over. That way you'll have a large code which solves a lot of problems. But if you don't craft them, if you don't arrange them, if you don't design them in a way that a well-designed software should have, then it will be a disaster. So this is where the craftsmanship of software engineer will be really useful. So that is what they're saying here. And again, they are reaffirming that if we rely too much on AI, we have risk of missing subtle bugs, we may have architecture flaws, vulnerabilities, and only skilled engineers will be able to catch those kind of things. So basically, a human engineer's knowledge is indispensable for both catching errors as well as driving innovation, because these agents will not be able to come up with the novel ideas, but human can. So that is what they are highlighting here. And then they're talking about the pyramid structure, because in an organization, if you take a pyramid like this, we'll have lot of junior engineers and a slightly less number of mid-level engineers and some senior engineers and some lead engineers. So this will be the normal pyramid structure that we will have. And they're saying that this pyramid structure is changing. If you don't hire people in this layer, then it is going to be a problem. So in a normal pyramid structure, they are explaining how team currently operates. So we'll have tech leads or senior engineers. They will plan the task. So they will have the details of the requirement, architecture. So they'll plan the task by creating smaller tasks. And then they will assign those tasks to early in career developers. They will go and implement them. And then they will send it back to tech lead for review. So this is the way that currently a normal team works without AI. Or they could have AI as well, but this is the way they currently operate. And in the structure, the generative AI that we currently have, things like Claude, Copilot, these are seniority biased technology. If you know what you're doing, if you know how to ask, if you spot the mistakes that are coming up with in the code generated by these agents, then you have advantage. You'll be able to take advantage of your knowledge. You'll be able to design a product really quickly. But it penalizes people who don't have the knowledge. If early in career developer uses the same tool, because of their lack of knowledge, they may not be able to create better system. Okay, they are using the same tool, but how they use and what knowledge they have gives them different experience, right? If you have knowledge, you'll be able to leverage that tool to deliver something quickly. If you don't have knowledge, you could create a disaster. So that could happen. And then they go on and say that there is a report which is published saying that after ChatGPT 4 release, employment of people aged between 22 and 25 has gone down. But at the same time, it's gone down by 13%. But at the same time, senior role grew. They're not saying how much, but they're saying that in this period, the demand for senior roles grew, but the entry-level engineers recruitment dropped by 13%. So this is why they are saying that this pyramid style is shrinking. The base of the pyramid is vanishing. That is what they're saying. Okay. So then they're saying that the solution is not to assume entry-level engineers will benefit from same productivity gain as seniors. We should not assume that. But we need to deliberately hire them and invest in them to make them better, to make them become a senior engineers. So that is what they claim as a solution. And they introduced this new concept called preceptor program. In preceptor program, what they are saying is early in career developers will pair with senior mentor in the real product development team. They won't be doing any artificial or tasks that are just designed to make them learn. They will actually participate in the real product development with the mentorship of experienced engineer. So this way, the preceptor. So preceptor is basically the person who helps the practitioner, which is early in career developer. So their goal is to guide and grow practitioner. So the objective is learning, not just throughput. So it doesn't matter if they are not able to develop as fast as seniors, but as long as they are learning, that should be the main goal. Okay, as long as they are learning, that should be fine. And then they are going on with another example and saying that using tools like ChatGPT is creating cognitive depth, and there are some studies which shows that people who used ChatGPT showed reduced brain activity, but people who are not using it showed higher brain activity. I don't know how much that is relevant to this paper, but they have included that. And basically what they are saying is understanding AI's strength and weakness, and having judgment to decide what to take and what not to take, and when to blindly trust it and when we shouldn't trust it, is a skill, and that will come from knowledge and experience, right? If you are a senior engineer who has done this kind of work in the past, you'll be able to immediately spot whether it is giving you a good solution or not. If you're not a senior engineer who doesn't have much experience, you may not be able to spot it. So that is the whole idea here. And then what they are saying is we need to include early in career developer in all aspects of software engineering. So we shouldn't just give them a familiar set of tasks. We need to involve them in debugging, reviewing the code, developing complex products, feature. All of those aspects should be involving early in career developers. So basically, when we do that, senior engineers has to play the role of preceptors, and senior engineers has to externalize their senior judgment. So they'll be making a decision based on what AI gives them, right? And they need to externalize that senior judgment, so it will be visible to the early in career developers, and they'll be able to learn from it. So that is the whole idea. So if we do this, we can avoid software engineering becoming a fading craft. Okay, so in AI, we don't want software engineering craft to go away. We want that profession to survive because it is still a very valuable profession. If we blindly start trusting AI and don't hire any early in career developers, then this craft will, this software engineering craft will slowly fade and disappear. So that is what they are saying. So when we have preceptor in an organization, they are saying that this is how it will look. We'll still have lead engineer or tech lead. They'll plan and assign tasks to individual developers, and those developers may use AI to implement them. But for each of these developers, we'll have someone called preceptor, and this preceptor is a senior engineer who has experience, and they will be able to guide these entry level developers or early in career developers to help them to work with AI tools and reason with AI tools. Whenever there is a decision making process, the preceptor will help the early in career developers to learn from that decision making process, learn from that decision that senior engineer is making. So that way these early in career developers will learn how they are making those decisions, and that becomes their own knowledge over a period of time, and they'll be able to make those decisions independently. So that is the whole idea. Basically what they're saying is when these early in career developers uses AI agent, they need to use it in a Socratic coaching mode, which is basically rather than asking for the answer, these agents should allow them to guess, allow them to come up with a different solution, and these agents should help them to tell what is right or wrong in their solution rather than simply giving them an answer. So this way these early in career developers will be able to learn using AI as well, right? So that is what they are basically proposing. So the whole idea is we need to invest in early in career developers, and with this preceptor approach, these early in career developers, even though they use AI to generate code, they'll still learn the software engineering craft from senior engineers, and they themselves will become a senior engineer over time, and the whole software engineering profession will survive because people will still have knowledge. They'll not be writing the code using hand, or they'll not be manually writing code, but they'll still learn and understand everything that is going on, and they'll have sufficient knowledge to make decisions as well. Like, they'll be able to spot when AI makes mistake, they'll be able to guide them properly. So if we don't invest on early in career developers now, we have a risk of software engineering profession collapsing. Okay, so that is what this paper says. I have slightly different opinion on this. Okay, first thing is, this paper assumes that all early in career developer will only learn through mentorship. They only learn from seniors. That is not the case. If you take myself, I have 20 plus years of experience, and I have learned from some of the seniors, but not always, right? So it depends on what kind of learning that you prefer and what kind of environment that you have within your company. Most of the time I learn by watching YouTube video or reading a book or taking a course, and sometimes with my own experience. So there are different ways in which people learn and become a better software engineer. It depends on their ability, their ways of learning. So, and that is the main problem that I'm seeing with this, right? So we still need to hire entry level developers or early in career developers. I'm not disputing that. But what I'm saying is, in order for them to become a seasoned software engineer, they are claiming that we need to use preceptor and they will teach them. I disagree. It may be one of the ways, but it is not the only ways. There are a lot of talented people who write books or offer courses. If these early in career developers takes those courses or reads those books, they'll still become a solid software engineers in the future. Okay, so it is not like, I don't agree that if we don't hire now, this profession will collapse. We're still going to have all this knowledge somewhere documented. People will still continue to write books and share their experience. And if somebody comes in later on, even if they don't have any mentor, they can still go through these books or courses and learn from that, and they can apply that in their job, right? So that is my view on it. But overall, this is a good paper. I'm not disagreeing with many of the things here, except one thing where this whole paper assumes that early in career developer only learn from seniors in the company or in the place where they work. That is the only thing that I disagree. But overall, it is a good paper. I hope this is useful. Thank you for watching. See you in the next video.